like to start?
Well, let's pull up the review. We can just...
Let's do one question each so we can, and if we have issues with it, then we just help each other, okay?
Okay. Well, Alma, why don't you go ahead and do the first one?
Okay, let me just, hold on.
Oh, you're good.
Churning, okay.
On the review from the reading.
Hold on. My computer's still churning.
Oh, you're good. I can go ahead and do the first one while you're loading yours. All right.
Yeah,
Number 1. What is the name of the... Well, do you guys all have your questions pulled up so I can just read the answers?
Yes.
Oh, there's music. Sorry, guys. An ad popped up on my... an ad popped up on my computer, so... And I had to wait 8 seconds to close it. All right, for number 1, I put this...
So are you reviewing where it says
on the individual
preparation or the group meeting?
The individual prep, because it's for the preparation.
The exam 1 review, right?
If I click where it says review, are you starting with question 1 where it says what is the name of the important statistical results? Is that where you're at?
Yes.
Okay. Yeah.
Yes.
And then I put central limit theorem.
Yeah, that's what I got.
Okay. Awesome.
So the number 2, I would do number 2.
Okay.
What is the name of the important statistical result that it says that when the sample size is large, the sample mean X will be close to the population mean? So correct me if I'm wrong, but I put the large low number from lesson 6.
Right.
That's right.
All right, that's good. Alma, you can do the third one because
so number 3 says which of the following variables is or are categorical? 1, it says the number of animals in the local zoo. 2, a randomly selected brand of toothpaste in a convenience store. And 3, age in years of randomly selected vehicles in a parking lot. So I put 1 as it being a categorical variable.
That one would be quantitative because it's doing like the number of animals.
That's right. You're right.
So you're thinking of the
it would be you're right. It would be the toothpaste.
Mhm. And
correct. That's what
I
got.
was wondering, what about number 3? I thought it was quantitative, but I'm thinking it's kind of categorical too.
Number 3?
Yeah, because it doesn't specify, even though years are numbers, but it's just not, it's just categorizing by age, which is just, a category. Like when you do gender, age, and stuff like that, so it's a category. It's not just a measuring. So that's the difference. The quantity is something that we can measure. So that was, it's just, we got to be careful with the details of the wording.
Yeah.
All right, Elizabeth, you can go ahead with number 4.
All right, the mean IQ test score in the U.S. is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of these 2 numbers is a parameter, and which is a statistic? I said that the statistic was 112, and the parameter was 100.
I got that too. Yeah, it was kind of confusing, but then I got to look into the description.
Yeah, a parameter has to deal with the population, and a statistic has to do with the sample.
Sample.
Yeah. All right, number 5.
So, want me to do 5?
Yeah.
It says Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' response to a proposed increase in property taxes? So I'm thinking that this one's more like where they tell you, what type of method are you going to collect that data.
Mm-hmm.
So I I'm thinking random. But hold on.
I put stratified because that's the one
Yeah.
where you take all the groups and you split them
Yes.
up by groups and then you do a random sample from each group.
Yes, that's what I did. Yeah, I got that one too.
Thank you.
Yeah, that's what I got. Yeah, it's kind of difficult to look, but try to. There are a few of them that are very descriptive, so you can just go ahead and as soon as you see it, you can just categorize. But there's two that is very confusing. So let me see if I got it right. Number 6.
Okay.
I got from the answer is simple random sample.
Number 6.
I was confusing with that one. I don't really know if I'm right. But since it's saying in the question say randomly, so I don't know if it was because it didn't say any specific groups or if it was a drawing.
Yeah. I put
so that's what it
was cluster because I take the based off of their classroom and then they randomly select a classroom and then they select all the students from that one group. So I said cluster because that's what cluster is.
Okay, good.
Does that make
that
sense?
was kind of it makes sense. So cluster, okay. Who's next?
I think I am. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names are selected to receive door prizes. Which type of sampling scheme was implemented? I said it was like a simple random sample.
Yeah, it says every time there is a drawing or computer stuff, it's just a simple random.
Okay.
So moving on to number 8. It says a special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100. Which type of sampling scheme was implemented? Stratified?
Yeah.
Yeah, that's what I got.
Me too. Alright, let's go and do number 9.
Okay, I'll do it. So
it says, I think 9 and 10 go together.
Correct, yes. But 10 is to create a histogram, so we had to do it on our own.
Yeah.
Right?
Right.
Okay, so it's a survey was taken of purchases at the Crossroad. So open the file on Crossroad purchases and use this data to answer question 9 and 10. Now, this is to be used with the SSPS, right?
Yeah.
In order to get the information. So I did a calculation, and correct me if I'm wrong, because I was like, let me go back and see the videos how to do it, because it's like, I forgot already. So for me, the mean was 4.77. Standard deviation was 1.91. The minimum was 0.84. 25%. Q1 was equal to 339. Q2 was 5.15. Q3 was 571. And the max was 1045. Am I right or wrong?
Your guess is as good
I'm
as
not
mine.
sure. I couldn't get my SPS to open.
What was that?
I said your guess is as good as mine. I didn't get to that.
You didn't get to that?
No.
Okay, what about you, Alma?
That was me, Alma.
Yeah, I couldn't open my SPS. It was being weird, so I had to reinstall it. So
yeah, okay, no problem. I think so. I was not 100%
Was it
sure.
pretty easy though? Like looking at it, was it something pretty easy to figure out?
Yeah, no. With you gotta go back to 2 different options. One, you are in SPS. You just gotta for the histogram, you gotta do groups, and then let me read because I put it legacy dialogues and then histogram. It's pretty easy. Once you have the information, you just sort it from smallest to largest, and then you select it, and then you can do analyze to get all the information. But it's right there. You don't even have to do calculation. It's just 2 clicks away.
Okay.
So it's pretty easy. Just I will suggest you to go and review the videos on how to do it. I think it was part 1 or part 2. There's 3 different videos, and I think it was lesson 4. No, sorry, between lesson 3 and 4, which it actually teach you that. So just go ahead and try to figure it out.
Okay. I'll have to do that. All right. Is it my turn?
Yes.
Okay. Jessica, I think I'm just going to skip all that reading, go to the question.
Yeah.
All right. 11 says, what is the value of the number that goes in the position marked with an A above? So I put, which box is that? I put it was negative 0.16. Is that right? I don't know if I got it right.
0.16.
37.91. Hold on.
So you find the mean, which is 37.91 plus 37.25 is 38.98 plus 38.16.
3046.
What was that?
What was that? You're looking for the mean, right?
Yeah, well, I was looking for box A, which is the deviation from the mean for the first one.
Okay.
So you have to take x, which is just 37.91, and subtract it from the mean.
So what was your mean?
The mean was 38.075. That's what I got.
That's what I got. And then you subtract that from the 37.91.
Yeah, that's what I did. And then I got negative.
How did you get the mean from? Just to calculate both of the middle ones?
To get the mean, you have to add all those numbers in the representative temperature column, and then you divide it by 4, and that's the mean.
Oh, yeah,
I did it. And then to find the deviation from the mean.
What I did was, so I don't know, because what I did was put it in Excel and add these 4 values, and then use the formula for average, which is the one you use it to find the mean. And actually, I got 3046. So I don't know. I will have to look again to my notes to see it.
Where did you get 3046?
Because I used the formula from Excel and the average to get the mean. So I got something different. But what was your again?
My mean was 38.07, and then my answer for number 11 was negative 0.16.
0.16?
Yeah.
All right, that's good. So I think I got it wrong, that doing it that way, I guess.
Okay. All right.
And so 12, what you got on 12?
I'll go ahead and just do this one since they're grouped together. So for 12, I got 0.6724.
0.6742, you say?
24.
24, okay.
Yeah.
I just want to make sure so that way when I do it, I don't get confused with it. All right. So who is next? Me?
Yeah, I think so.
So what quantity is equal to the sum of number? But then I got it wrong because I didn't write. They didn't do the mean to calculate the mean. So.
Oh, it's okay. What did you put?
So I put it. None of this is correct, but I don't know how. Since I don't. Since it's not matching.
Yeah, I think it's the variance.
Okay.
What is the question exactly asking? It says, what quantity is equal to the sum of the numbers of the square? Oh, yeah.
So the square deviations column is just asking what it's called when you add all those numbers together. And I'm pretty sure it's
that's a variance.
Okay.
Yeah, so it's the same for everything. Yeah, correct. You got it right, yeah.
Okay. All right, Alma can do 14.
Okay. So it says, what is the standard deviation of these temperatures?
Yeah.
So
I was kind of confused how to do this. Well, the way I did it, I just added the second column, but I'm not sure if that's right.
Well, once you have the result from...
No, go ahead.
Okay, so once you have the variance, which is the sum divided by n minus 1. That n minus 1 means the 4 samples that you got minus 1. So it will be your result from the sum divided by 3, because you are subtracting 1. And then that result will be that result you're gonna take the root, what is it, the square root of that, and then you get the standard deviation.
Okay, so
You confused me.
are you using
You're using Excel, aren't you?
What was that? What was your question?
You used Excel to figure that out?
No. That's the formula we use it on the book.
Yeah.
So
the sum that you keep saying, are you referring to the sum of the third column?
The square deviation, yes.
Okay. So you would take. Let
me see if I can write it down so it's better for you to see it. I don't know if that's gonna help because my handwriting is not that well. And then the variance is this. You just say is the sum of all the products divided by n minus 1, right?
Okay.
So whatever you got in the sum of the third column, you're gonna divide it by n minus 1. And in this case, n is the number of samples. So since you got 4 of them, the 3791, the 3725, all of them each of them is 1. So you got 4, and you're gonna subtract 1, which is the formula. And then that result you're gonna get the standard deviation formula is to do the square root of that result that you get from variance. Like, let's say,
right.
And that's the formula from there. That I just look back to my notes, and then it shows me that. So I didn't use Excel for that.
Okay. So when I did what you said, I got 0.715. Is that right? Did you guys?
All right. Let me see. You say that you got from the variance. What was your answer for the sum of the variance and in the top when you added all the values from the square deviation?
I got 1.5342.
Okay, hold on. That way you're gonna divide it by 3, and then it's 0.5114, right?
Yeah.
All right. So then you gotta look for the standard deviation, which is the root.
What happened?
Of the 0.5114. Well, it's supposed to be 0.715. That's what you got? Yeah, that's what you got. Yeah.
Okay, well, it was really helpful because I was doing that completely wrong.
No, it's okay. We're here to help each other. So, 0.71. Is everybody clear with that?
Kinda.
Just gotta follow the formula. If you need to do
the formula.
You see the formula now?
Yeah.
For the standard deviation, just follow what they say. I mean, just once you get the information on the table, it's just to put this
plugging in the
data in the just to put in the numbers in the right places, and then just do the calculations. It's nothing like the other word. All right, so true or false? Under certain conditions, the standard deviation can be negative. That's false. The standard deviation never is never negative. So we got that right. Okay.
All right, number 16.
16 is in the same study, the researcher placed thermistors, temperature sensors in the 3 seals named Chick, Starburst, and Patty near the spinal cord and brain in the extradural vein. They placed thermistor in 6 of their seals named Sears, Richard, and blah, 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 blah. In their aorta, the largest artery in the body, finally, they placed thermistors in 4 other seals named body, Roberta, Larry, and Pierre. In their hepatic signals, the results from this study are summarized in the table below. And for some reason, I don't know why I didn't do this. Which location resulted in the most consistent temperature measurement from one seal to another? Justify your answer. So in this question, do we have to do the same as we did before?
No, you just need to. You don't need to do any calculations for this.
Oh no?
No,
You're
it's
just trying to
more
figure
observation
out
of the numbers of what you see. So if you go to number 17, it says in your own words, without using any mathematical symbols, explain the standard deviation. So if you look at it, each there's different numbers of seals that each one had placed. But if you go to the third column, remember your standard deviation is from that one going out.
Mm-hmm.
And then it just tells you just to explain, number-wise what's occurring or what you observe.
Indicate the experience of the deviation variables whole. So in this case, we're going to see the three results that we got in the third column, right?
Mm-hmm.
Okay. Then it's in our own order. Okay, that's good. And that will be the 17. So we move forward to the next one, right?
Okay. I guess I can do this one. Okay. The number of hours students spent studying for an exam are recorded. Data represented by the box plot below. Use the box plot to answer questions 18 and 19. So 18, the minimum is 2, Q1 is 4, the median is 6, Q3 is 8, and the maximum is 12.
Yeah.
I think the maximum is 14.
Oh, it is? You think so? Oh, yeah, you're right.
Remember the little circle? Even if the circle is at the beginning or at the end, that's the maximum.
Yeah, I forgot about that completely.
Yeah, it's just details. I'm trying to look for the details because I know we're going to have issue with that later on.
Yeah.
All right, that's good that I help you. 19. What percentage of the data lies between 4 and 8 hours? So in this case, I was kind of confused because I was like, okay, the 25%. So since Q1 is the 25% of the information, right?
Mm-hmm.
I think I put between 25 and 50, or it's just 50?
It's 50 because it starts at Q1 and then it goes to Q3, which covers 50%.
All right, yeah, I was kind of confused with that. Thank you.
Yeah.
So,
All
okay.
right.
Number. Go ahead. Hello?
Go ahead, Alma.
Oh, no. Do you want me to do 20?
Yes. I didn't do this. It was very difficult for me to kind of figure it out which information we had to actually work with it, because it's a lot of ppm and the mean, so I don't really know if we gotta do two different calculations or how this is done.
Let me find the thing first. Hold on.
When I exercise, it's just this long. It's just very confusing for me to just focus on what kind of information
what it's asking. Well, let's read the question first. It says, an observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrates concentration above 10 ppm, meaning parts per million, are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water supply is between 1.59 and 2.5 ppm. And the value outside this range is unusual. We will assume that 1.59 is the value of blah, 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 and blah, blah, blah to equal 2.59. It is reasonable to assume the measured nitrate concentration is normally distributed. Using this information to answer questions above 20 through 22. So it says estimate the mean of the measured nitrate concentration in Rexburg. So it says the concentration usually is 1.59 and 2.52. So to find the mean, you would add those two and divide by 2. Would you not?
No, what I did, okay, so that little U sign, it's called mu.
Yes.
So I did mu minus 2 standard deviation equals 1.59, because that's what it says in the problem. And then I subtracted that whole thing from mu plus 2 standard deviation equals 2.52.
What is the whole thing that you mean? 1.59 minus 252? That's what you're saying?
Hold on. I'll share my screen real quick so you can see.
Good, yeah, because I was like, okay, what's the whole thing?
Can you guys see my screen?
Yeah.
Okay, so I took this.
And substituted it for...
Well, no, I didn't substitute it at all. I just took that, and I said that it equals this. And then I said that whole thing, and then I said that was subtracted from this equals this. So, and then when I subtract them or whatever, this and this will obviously cancel out because -2 plus 2 is 0. So then you're left with 2 mu equals 2.52 plus 1.59, which is 4.11. And then I take 4.11 divided by 2. So then I get 2.05, if that makes any sense.
But Ellie, let me ask you a question, just because my kids came and interrupted me.
Yeah, it's fine.
So where it says the mu minus 2 from the standard deviation, going back to the question, where did you see the standard deviation? Oh, two standard deviations away from the mean.
Yeah.
So 2 standard deviation from the mean is in the rule of 68, 98, and 97 or something like that? Does it have to do anything with that?
No, it's just like using regular algebra. So maybe I can type it on Microsoft real quick so you guys can see.
Yeah, do it bigger because that little letters doesn't work for me.
1.59. Minus plus 2 standard deviation equals 2.52. Sorry, I'm trying to draw it out for you guys real quick.
It's okay, it's okay.
Equals 1. Almost done. Okay, now I can show you guys. Screen share. Alright, so if you go back to the chat thing, you can see my screen.
Can you do it bigger? I don't know if it's myself.
Oh, yeah, I can do it bigger. Hold on.
Thank you.
Just zoom in.
That's good.
Okay, So in the problem, it says that the first mean or whatever is 1.59, and the second one is 2.52. So that's how I know that those two equations are what they are.
And you got the mean by adding or doing the subtraction from the 2.5 and then dividing it by 2, correct?
Yeah. So if you just look at my screen, you can see that, like, if you add the mean plus the mean, that equals 2 of the mean. And obviously negative 2 plus 2 is just 0, so that would just go away. And 1.59 plus 2.52 is 4.11. And then I have to get rid of the 2 that's right next to the mean. So I have to divide the mean by 2 and divide 4.11 by 2 to get 2.05. Does that make sense?
I think so. Let me just do that.
All right, and I just knew how to do that because they gave us those two equations, and they said that we know that the mean is 1.59 and 2.52 kind of thing. So. You guys understand that?
Yeah, I get 418 though. I get 2.09.
Oh, okay. It's probably just my rounding. So, yeah.
Okay.
Okay. Well, then we can do the next problem.
It says estimate the standard deviation of the measured nitrate in Rexburg.
So for that one, so in the last problem, question 20, we found out that the mean is 2.05. So you just get one of those equations that it gives you, and you substitute the mean in
for the
mu sign. So I got 0.23, but I mean, your answer might be a little bit different since you and me rounded differently.
Yeah.
So it should be like close to 2.23 though.
But Ellie, you know how you said that you substituted the 2.05 that you got for the mu sign?
Yeah.
And what did you then do the minus 2 standard deviation?
I did mu minus 2 standard deviation equals 1.59. And then when I substitute 2.5 in, all I have to do is subtract 2.5 from both sides to get the...
Oh, you did the basic algebra thing?
Yeah. So then you end up with mu equals 0.23 because you have to end up subtracting both sides and then you have to divide both sides by -2.
Okay.
Yeah, I think that was lesson 2, I believe, right?
I'm not sure which. I'm pretty sure it is.
Okay.
Yeah, I seen that. I didn't quite.
Yeah, I think it's lesson 3.
I don't remember what it was. Yeah, maybe lesson 3. So what would be the number 23? Because I didn't do it right. I mean, I was kind of confused with between the 23.
All right. For 20. Oh, we didn't do 22.
Oh
22,
no.
22. Oh, sorry. 22 says between what two measured nitrate concentrations do approximately 68% of the data values lie? I put where is it? I put -2 and like 2-ish. It's like some weird decimal, but it rounds to 2.
Okay.
And I just use the normal applet probability thing to do that.
How did you know to do that?
I did. So if you go to the normal probability applet, at the very top, you can put in. Hold on, I'm pulling it up real quick. At the very top, you can put in 0.68, and then you get the z-scores. And then once you get the z-score, you have to solve for x in the z-score equation that we have. So you just have to use algebra for that one too to find x, because we know that the mean is we found the mean in question 20, and we know the standard deviation from question 21.
Yeah.
And then we know that the z-score is whatever is in the normal applet after you put in 0.68. So then you just solve for x after that.
What is that, Soil? She's showing us something.
Oh.
I guess you got it right. I can see it.
I can see her, but I don't see what she's pointing at.
The formula to do that. Yeah. She's showing us the z-score formula.
Oh, I see.
Okay, yeah.
Yeah. That's it.
That's good.
All right. 23. You said
Okay, so then solve for x. Okay.
Okay. What is
the standard deviation? Then you will use the standard deviation formula, right? The one that doesn't have the square root, right?
Yeah. Oh, I didn't do it. I don't know why. Yeah, you should.
Yeah, because the one for normal distribution, it doesn't have the root square. You know, the standard deviation divided by n.
Yeah.
Yeah, I didn't do this because I couldn't understand what was.
I said that the mean was the same thing as it was from the parent population, but I don't know how to get the standard deviation because there's no sample size. So if there's no sample size, that just means that the standard deviation is the same thing, but I feel like that's wrong.
Oh, got you.
Yeah, you see, like, even if we tried to get a standard deviation, we would get the same answer, so I just don't know what's from that.
Okay, that's good.
I wish we had the...
All right, so let's do the...
I wish we had, like, a way to compare to say, oh, yeah.
Yeah.
This is right or this is wrong.
I wish we got the answers, yeah.
Yeah.
All right, who wants to read that?
It says the
admissions...
Go ahead.
The admissions committees for most masters of business administration MBA programs require the graduate management admission test GMAT as part of an application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MAC program in the School of Accountancy at BYU is 500, but it's rare for students with a score less than 600 to be admitted. Use the information to answer question 24 through 32. So, what is the probability that a randomly selected students will score about 542.3 on the GMAT? So the formula that I used was z equals x minus the mean over the standard deviation.
Mm-hmm.
Now, the x, I was kind of confused with this one too, but in this one I tried to do it anyway. The x in here will be the 542.3, the one that is in the question.
Yeah. So that just means it's just asking what's the probability that someone will score above the mean. So that would just be 50% because the mean divides the data in half.
Yeah, but then if the score above, which is in the question 542.3, and we subtract it from the mean, which is also 542.3, right?
Mm-hmm.
Divided by 120.54. Then it's going to give us a result of 0.
Yeah.
Oh, okay. So I was doing it right.
So in the normal applet thing, if you just put 0 in.
It gives a standard deviation of what was the standard deviation?
This was like the question on the last homework lesson that we had, huh?
Yeah, kind of does.
Why is my screen froze? So, what would be the standard deviation? My screen just froze. I don't know what's going on with my computer.
Good. The standard deviation is 120.54.
Also, it stayed the same as it is, right?
Yeah.
Okay, good.
So, number 24 would just be 50%. Because you have to use because you have to use the normal probability applet. And if you put 0 in for the z-score, and you find out what's above that, it's just 50%.
Oh, okay. So they want the answer on, oh yeah, because it's a probability. Okay, that's good.
Or that I see it at like 0.50. All right, 25 says, what is the probability that a randomly selected student will score below 600 on the GMAT? I put it was 0.684. And for number 25, you just do the exact same thing as you did for 24. It's just a different number.
But then you're gonna use the x is in 600?
Yeah. So you do 600 minus 542.3. And then you divide. What was that?
That give me a result of 0.479. Is that what you got for that?
Let me check real quick. I didn't write it down. 600 minus 542.3. And then you divide that by 120.54. Yeah, you got 0.479. But then you have to put that into the applet thing.
Correct, because that one, now when you say, because this is what got me by results on that specific question. When they say below, do you just do both parts, the right, the left? It's a positive result. The right and the middle, or just the right one?
I don't know for what. Everything for below. You do everything to the left of it.
Mm-hmm. To the left. Everything to the left. So when they say above, it's everything to the right.
Yeah.
So what was your result on this one?
I got 0.684 for the probability.
Yeah, because I did the Z-score then last time, then I didn't do the probability. I was like, oh my gosh, how did I forget?
That's funny. All right.
So 26. For the 26, then it will be 0.684 or not?
No, it's asking for above. So it would be.
So it will be everything. 316.
Yeah.
Oh, okay, then I got it wrong. Okay, so on this one, it will be the same Z-score information, the 600 minus 542.3 divided by 120.54, but since it's asking for above,
yeah,
then you select the different data, right?
Yep.
Okay, that's good.
All right, who wants to do number 27?
I have no idea for 27 and 28.
Oh, it's okay. We can help you. Okay.
I have it with the 27.
Okay.
If I don't know if I'm right, let me see if you got it right, Alma.
Well, I didn't even attempt to do it.
Oh, it's good. Go ahead.
Yeah,
go ahead and
I tried to do it, but not all of them. Okay, so 27 is 624.61.
I got 696.83.
All right, so what kind of formula did you use? I used the x equals u plus under parentheses z times the 0. Z times the
Diego.
Z times the standard deviation, right?
Yeah.
So what will be the information, the one that you have? The u will be 542.3 plus. Oh, we have to calculate the Z-score first, right?
Well, yeah, you have to put it in the normal applet and put in 0.1 for the area. And then for the Z-score, when you put in 0.1 in the area, you get 1.282.
Can you say that one more time?
So you go to the normal applet, and then you put in the area, you put 0.10 because it's asking for the 10th percentile. And then,
correct. That was getting me crazy. I was like, how do you do that?
And then when you enter that in, it gives you a Z-score, and the Z-score is 1.282.
Now, do we have to click in the applet any specific area, the right, the left, the middle?
No, it doesn't matter. It still gives you the same Z-score. Yeah. So then once you get your Z-score, you have to multiply the standard deviation, which is 120.54, and then you get a number, like it's 154 or something, and then you have to add the mean, which is 542.3.
Add the mean.
Yeah, because on the Z-score, in the Z-score equation, you're subtracting the mean, so you have to add it to get it on the other side.
Oh, I didn't know that.
Yeah.
I thought it was just the formula, just to use it and that's it.
No. You can like move it around and stuff, so that's how I got my number.
Oh, yeah, the euro, the mean, yeah, because I see it in the beginning of the formula. Let me see if I got it. Hold on, just give me one moment. 542.3 plus 0.82. Yeah, you got it 696.58, right?
Yeah.
Okay.
All right.
And then that
number
is just the
28.
result. Okay, that's good. 696.58. That's good. Thank you.
Yeah.
Then 28, you do the same, right? But instead of putting 0.10, you do 0.90.
The only weird thing is when you put in 0.9, you get the same z-score.
Oh, wow.
Yeah, so the answer would just be the same, which I thought was really weird.
What would be the same?
Yeah, it didn't make any sense to me, but when you put it in there, it's the same, so.
Okay. Don't we have to do any?
You got the same answer for 27 and 28?
Yeah. The same z-score, so the answer would be the same, which I thought was kind of weird, but I guess it kind of makes sense.
Well, it is what it is now. I'm not sure about it, but it's usually because that I had the issue too in the quiz from the homework when it says more than and less than of the 90. Because after 50 is certain equation, and before 50 is another equation, right?
Yeah.
So I don't know, but
you wouldn't think so just by reading the two sentences, because 10th percentile and 90th percentile, if you're looking at two things, the values of those should be different.
Well, they're kind of still related because when you're in the 10th percentile, 90% is above of you, and when you're in the 90th percentile, 10% is still above you. So I mean, I feel like
that's right.
it would make sense that the z-score is the same. All right, 29.
And the 29 and 30, in that question, do you have to use the SSPS to get that information or not?
What did
or
I
how can
do?
you get that one? Because I didn't do those one.
I just found, because you know that the Q1 is just 0.25, the 25th percentile. So you just go to the normal applet and put in 0.25, and then you find the z-score, and then you solve for x.
So that whatever z-score is in there, just put the answer in there?
Yeah, so it's just like how we did number 27. But you instead of using 0.1, you're using 0.25.
Oh, okay.
Yeah.
That was easy.
And you do the same thing for 30, except for you're using 0.75.
Correct. Yeah. That's good. Oh, okay.
So for 29, I got 696.83. I mean 623.54. Sorry.
623.54.
Yeah, and then I got the same thing for 30, and I think it's because of that whole 25-75% thing.
Yeah, I guess so. Okay, I just have to review that because I was kind of confused on that.
Yeah, no problem.
So let's see. Consider a simple random sample of N15 students taking the GMAT. So 31. What are the mean and the standard deviation of the distribution of sample mean score for all such samples? Now, I don't know if I did it right, but because I didn't see more information, so I don't know if we had to add the 500 and 600 or just put the mean 542.3 and the standard deviation 120.54.
For the mean.
For the mean, it would be the same thing, the 542.3.
Yeah, because it's a normal distribution, and it says that in the long paragraph.
Yes.
Yeah, and then the standard deviation, for that one, you have to take the standard deviation that it gives us, and then you have to divide it by the square root of 15.
Yeah.
Because 15 is the sample size.
So what was the standard deviation here? What was it?
It was 120.54.
It was 120.54.
And then you divide it by the square
You
root
divide
of
it by
15.
the square root of 15.
Oh, that's cool. Okay.
That much I know.
Thank you.
The other stuff I don't.
Okay, that's good. Okay, so you're just replacing the formula.
Yeah.
Oh,
And I got
who wants to do
31.12.
31.12?
Yeah.
Okay, thank you.
Yeah. All right, 32. What is the probability that the sample mean GMAT score for an SRS of n equals 15 students will be greater than 600?
With this one, you use the applet, right? You go through finding the z-score.
And then you have to use the same equation we've been using for the past few problems, except for when you multiply the z-score by the standard deviation, you need to make sure you use the standard deviation that you got from answer 31. So you would do 600 minus 542.3 and then divide it by 31.12.
Also, you don't use the 120.54 anymore.
No, not at all. And then you get a z-score of like 1.854. And you're trying to find...
What was the z-score again?
1.854. And then you're trying to find greater than, so you just need to highlight to the right. So
but when they say it's greater than, it's just all the way to the corner, only the little part, the first part, or is in the middle?
Yeah.
The little tail, right?
Yeah.
Okay.
But
so
Ellie, can I ask you a question? Can you do the flip thing on your computer where you can show it? Because once you highlight that little tail of what's greater than 600, how do you then get that percentage or that area, like right there?
That's the percentage. It's your probability is 0.0319, so your percentage is just 3.19%.
Okay.
So when you find your z-score, you just put it in here, and if it's negative, you put it on this side. And then you're trying to find anything that's greater than it, so you highlight everything to the right of the red line. Oops, I just moved it. I didn't mean to move it.
And when you highlight it, that probability of that area is the 0.30 that I'm looking at right now?
Yeah, that's the probability.
Okay.
Now, it's not in here, but let me ask you something. When is the time that we, let's say you have highlighted the blue, right? But what about if we highlight above? What would be the term? Is it between? Is it grade? You say it's not graded because grade is... This
is what's the probability that it's between. It'll say something like that. And then everything like this is less than.
But without the middle highlighted.
Without the middle highlighted? Oh, I don't think you're ever going to see a problem like that. It'll say like the probability that it's less than or greater than.
Yeah, because sometimes I see that they click both areas together. I think the last exercise on the homework 7 has that problem because I just used the right one and then it wasn't right. Since they give you 2 chances, I say, let me try the middle one too. And then the answer was right. So I'm kind of confused in that terms. I know greater than is...
So when you're doing your problem, if your z-score that you get is negative, you need to put it in on this side. Yeah. And then in the question, if your z-score is negative and it's asking to the right of, it's to the right of that negative red line.
Oh. But if your z-score is positive, tail, or just the middle?
If it's negative and it's saying greater than, you have to start at the negative line and then do greater than that line. Or if it's less than...
So then it will take the
only
middle part too, right?
if you calculate your z-score and it's negative. Yeah.
Oh, okay,
gotcha. If the z-score you calculate is positive, then it's above that red line or below the red line kind of thing. So you just have to keep an eye on your z-score and make sure it's not negative or positive. You need to make sure you know which one's which.
All right, ladies. Thank you very much for your help.
Yeah. So do you guys want to work on a group quiz together? Because I am running out of time.
What's that, Ellie?
Do we have the group thing?
I think we have like a group quiz, but I can't really stay on that much longer. So, do you guys just want to take it on our own, or?
Can we take it on our own?
What was that?
Can we take it on our own?
Yeah.
Okay.
We don't have
If
to
it
take it
works best
together.
for everyone, that's okay.
Okay, let's do that then. And then we all have each other's emails, or I can email everyone and make sure everyone has everyone's emails. And then
Yeah,
if we
that
need
would be
help, we
good.
can ask. Okay.
That's
well,
good.
when do you guys want to meet next? What works for everyone? What day? Let's start with the day.
Wednesday or Thursday. When do we
Okay.
have to meet next, though? What's due next?
It's
Hold on.
due Thursday at midnight.
Okay, so I can meet Wednesday. I'm trying to think of what my days are like. Next week is going to be really hard, Ellie, because I'm working full time next week.
Oh, it's okay.
Um,
We can always just catch you up later.
But this week, Wednesday at 5:30 would be okay.
That's Pacific time. Okay.
So this week, what time are we meeting?
What's best
Wednesday.
for you?
I'm here, but I just don't want to be so late here because,
Yeah.
as I say, I'm in Georgia, so it's Easter time. But as early as you, both of you, I know Soila can do it after 6 o'clock, but I don't know.
6 o'clock your time, or
What's the
6
best for?
o'clock what time?
No, Mountain Time.
Mountain time?
Okay.
Mm.
Yeah, it's 9:30 her
So-
time right now. Okay.
So-
So we can do 6 o'clock Mountain Time.
I can do Wednesday morning.
Does
No,
that work for
Soila
you,
is
Zoila?
Soila is working. No,
Okay.
Soila works during the morning.
All right. So do you guys want to do it Wednesday evening?
Yeah, I would prefer that. I'm not gonna be there since I'm gonna do tomorrow the exam. It's just gonna be too much between the exam and to cover the class.
Okay. What time did you say you can meet Alma the earliest on Wednesday? After work?
Probably 5:30.
All right. So that's 6:30 Mountain Time. Is that too late for you guys?
No, I'm fine. That's good with Soila too.
Okay, so 6:30 Mountain Time. I'll go ahead and send out an invite tomorrow night, so you guys can just join the call on Wednesday. And if you guys don't get an invite, just email me, and I'll send another one right before the meeting on Wednesday.
And can you please send me your cell phone number so that way we can, in case I have a question, I can relate to one of you.
Yeah.
Okay.
I can actually just start a group chat on Google Hangouts, and then you guys can all just put your cell
that's
phone
great.
numbers on there.
Okay.
Great, thank you.
Yeah. All right. It was nice meeting you
Thank
guys.
Nice meeting you.
All right,
Good night.
nice to work with you, ladies.